guys, in this lesson, we're going to look at bisectors. So we're going to look at segment bisectors and angle bisectors, and what does that actually mean, and what does that look like, and how can we apply that? So by definition, a bisector is something that cuts something directly in half. Okay, so bi meaning two, and so in geometry, we're not only just cutting it, but we're cutting it exactly in half, which means it's going to have the exact same piece on each side of that bisector. They're going to be congruent, either sides or angles, whatever we're talking about here. So for a segment bisector, it's just a line or a segment that bisects or cuts another segment in equal parts, okay, in two equal parts, basically. Make sure you note that's going to be two equal parts. So you can see here that if I were to name this maybe segment AB, and we named this intersection point M, then AM here is going to be congruent or equal to segment MB, okay? So that's what we're looking at here. So the bisector cuts exactly in half. So each part, so this piece here, A to M, is going to be equal to M to B, okay? Or B to M, either way. And then an angle bisector is going to be a ray. Remember, that's where it has one endpoint and it continues on, that bisects an angle in equal parts. And again, this is two equal parts. So make sure we know that. So you can see that this angle AOC is going to be congruent, which is that little line with the little tick mark through it, is going to be equal to COB. That little line with the little tick mark in there. So those two angles are going to be congruent. So if I know the entire angle, I can find out what half of it is if I have an angle bisector. So a bisector cuts it exactly in half. Not just cuts it, but it cuts it exactly into equal parts. So let's take a look at this as far as examples go. So below we have AM is 25, and then what's the length of AB? So just go ahead and labeling this. So A to M is 25, which means M to B is going to be 25 as well. And this is asking for A to B. What is the length of AB? So all the way from here to here. So I just have these two. I have 25 and 25, so doubled. So 25 and then plus 20, another 25, which is going to give me 50. So the AB is just going to be 50. It's double that. So pretty straightforward there. It's going to get a little bit more challenging, but let's take a look here. This time we have an angle bisector. It says AOB. So when we name an angle and we name it with three letters, just trace those letters essentially. So what I'm talking about is A from AOB. There, this whole angle. So the whole angle is going to be 37. So this whole angle here is going to be 37 degrees. It says, what's the measure of AOC? So remember, just trace it. So AOC. So it's asking, what is the measure of this angle? Well, since I have AOC is going to be my angle bisector, I know that each angle is an equal part. So therefore, I know that basically I can just take 37 divided by 2, okay? Or if you want to get a little bit more algebraic with it, you could say that this is X and this is X, and I have two X's is going to be equal to 37. Either one works out fine. So if I work it from there, if I have 2x is equal to 37, again, look what I'm going to do, just divide it by 2. And so x is going to be equal to 18.5 degrees. So the measure of angle AOC is 18.5 degrees. That's how you would want to make sure you label that. And you don't want to label it just angle O, because angle O could mean there's actually three different angles it could be talking about. So that's when we have to use the three letters there, because it could be confusing on just what is angle O. All right, so this one, it says segment MN is bisected by line xy, which intersects mn at point J. mj is 4x plus 10, and nj is 10x minus 8. So what's the value of x? So what we have here is what we need to draw it, essentially. So I'm going to have a line here, and that is going to be, and this is segment, so it has endpoints, m, n, okay? And it's bisected by a line, so I'm going to do the bisecting line in red. And so this is xy, and this is a line, so it has arrows, so just kind of refreshing our vocab on that. And then it says it intersects at point J. So this is the intersecting point, and it says that mj is 4x plus 10, and nj is 10x minus 8. And then it says, what is the value of x? So basically solve for x. Well, I know that these two, this part is equal to this part because it used the word bisected, which means cuts exactly in half, two equal parts. So I'm going to have, I drew my vector too big. So I'm going to have 10x minus 8 has to be equal to 4x plus 10. And then I'm going to just solve. I'm going to move 4x to the left. And so I have 6x minus 8 is equal to 10. I'll add 8 to each side, and 6x is equal to 18. Then divide by 6, and x is equal to 3. So that's what it's asking for. So you'll have to do that. You would need to have the picture there, be able to draw the picture by the words stated, and then be able to set that up and solve the equation. All right, the measure here, we went ahead and drew it for you. It could say that AOC is the angle bisector and start labeling all of those, but it went ahead and drew that here. So the measure of AOB is 48. So the whole thing, AOB, is 48. So I know that each part, so if OC is the angle bisector, it cuts it exactly in half, then I know that each angle is going to be half of that, essentially. So what's the value of x? I know COB is 3x plus 9. So COB, just this part, is 3x plus 9, and then solve for the value of x. So basically, there's two ways I could do this. What I'm going to do is I'm going to go ahead and solve and say that I know that this is going to be 48 divided by 2, which is 24. I know that from angle COB is 24 degrees, and I know that that is also 3x plus 9 has to be equal to 24. So then I'll just go through here and solve for x. So I have 3x is equal to 15. And then I'll divide by 3 on each side. And so x is equal to 5 in this instance. So just kind of, this is, I would say, something that is, we're just kind of taking a quick halt from triangles and just refreshing our mind on bisectors. And because we are going to need it here in just a little bit, knowing that bisector cuts it into two equal halves or two equal parts. So that is segment bisectors and angle bisectors. Now it's time for you to practice with your skill check.